Hi, so today we're going to talk about Chapter 7, question number 7.14. And the question says, an ideal spring of a negligible mass is 12 centimeters long when nothing's attached to it. So when you add a mass of 3.14 and 3.15, it hangs to 13 centimeters long. So if you wanted to store 10 joules of potential energy in the spring, what would be the total length? And assume that it continues on Hooke's law. So first of all, we read the question. Now it's time to do the free body diagram, or a sketch of what we read. So in my mind, I assume that it's going to look like this. This is going to be 12 centimeters. This is initially. Let's call it A. So for B, it's going to have the same thing, the spring, with a mass at the end. That's going to be 3.15 kilograms. And the length of that is going to be 13.4 centimeters. Okay, now we visualized how the spring with the weight and the stretch is going to look like. Let's try and solve it. So we know from previous chapters that for a spring, F equals K of X. Okay, so now we know what's F. It's mass times gravity. And we have X, which is the length. We're trying to solve for K, the constant. So K equals F over X. So as we said, F equals to mg, which is the mass, because it's going to be in a vertical way, so it's going to be the normal force, which is mg. And we have the length, which is going to be in this situation the change of X. So m is going to be 3.15 times 9.8 divided by the length. But first of all, we need to convert it from centimeters to meters. So it's going to be what? 13.134 minus 0.12. And that's going to give us so that divided by the sum, the difference of 0.3 minus 0.12. So this is going to give us 2205 newtons per meter. Okay, so this is the constant we have. So now we're trying to know so the question says the potential energy. So this is an elastic potential energy, and we know the equation for that is going to be equal. The elastic potential energy equals 1 over 2 kx squared. So we know what's the potential energy, which is 10 joules. We know what's k, we just found the number. And we need to solve for x. So basically x is going to be equal to, we multiply both sides by 2, so it's going to be 2 potential energy over k, and we get the square root of that because we have it squared. So plugging in the numbers, we're going to get the square root of 2 times 10 joules of the potential energy divided by the number we have, 2205. And that's going to be equal to that's going to be equal to 0.095 meters. Okay, so now in this case we need to change it back to centimeters because we're going to add it with a length. So it's going to be 9.5 centimeters. Okay, now in this situation we have two types of lengths, when it's compressed and when it's stretched. So when it's compressed, so first of all we have the 12 centimeters. We add what we got, which is 9.5, and we're going to get 12 plus 9.5. It's going to be equal to 21.5 centimeters. At the same time, we subtract what we have, (9.5). This is going to give us 2.5 centimeters. So these are the total lengths. We have two. One when it's stretched and one when it's compressed. Thank you.